Hi, everyone. In science, we often use really, really, really big numbers or really, really small numbers. For example, let's say we wanted to know how many hydrogen atoms are there in 1 gram of hydrogen. Well, the answer is 602.000.000.000.000.000.000. Wow, that's so many atoms. So that's really kind of inconvenient for someone to write, but also for the reader to read. And so we instead, when we're dealing with really large or small numbers, we write numbers in scientific notation. It's much better just to say there are 6.02 times 10 to the 23 atoms of hydrogen in a gram of hydrogen. That is much quicker and easier to read. So this number is scientifically notated. To scientifically notate a number, what you do is you write just the leftmost digit of that number to the left of a decimal. And then you can have more digits if you want. And then you multiply by 10 to the some positive or negative whole number. So let's say that we had 5,623. To scientifically notate it, we would want to sort of move our decimal. Right now, there's an imaginary decimal right here. You can move that to the left so that there's just one digit to the left of the decimal. So move it once, twice, thrice. And that is going to change your number to 5.623. But also when doing that, that's going to take this, which was times 10 to the 0. No, that's just 1, so it had no effect. There was an imaginary 10 to the 0, and moving the decimal 3 times to the left is going to make that become 10 to the 3. Yeah, it's all kind of summed up in this staircase. If you had a 10 to the 0 and then you move the decimal 3 times to the left, then that would soon become times 10 to the 3. So you can see this number is the same as that number. This is 5,623, and this is 5.623 times 1,000. So that's the exact same value. Now, what if you were dealing with a small number? Again, you can move the decimal, move it to the right, so that there's just one non-zero to the left of the decimal. So move it once, twice, thrice, so that we get 7.72, and having moved the decimal to the right, where originally we had 10 to the 0, we're going to go to 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. All right, so this is 7.72 times 10 to the minus 3, or 7.72 times 0.001. Exact same value as up here. All right, and then finally, sometimes you need to get out of scientific notation, like if you wanted to plug into a calculator, say. So let's say we had 4.23 times 10 to the 3. To get out of scientific notation, we just want to move the decimal enough to get rid of this 10 to the 3, to turn it into 10 to the 0. So move it, let's see, it's 10 to the 3. To turn it to 10 to the 0, we need to move once, 2, 3 times to the right. So there we are, 4,230. And finally, what if you're dealing with a small number, less than 1? Okay, so you want to get rid of 10 to the negative 2, then you move 2 times to the left to turn it into 10 to the 0. So move our decimal once, twice. There were some imaginary zeros here. So now we have 0.0792 times 10 to the 0, or 0.792.